Hey y'all, so today we're going to be going over the complex zeros and using the fundamental theorem of algebra. So the first things you need to know are that if you have this a plus bi here, the conjugate is a minus bi. So looking at the conjugate, it's really just that I is flipped from positive to negative. So let's go into the first one. The first one we know that there's a polynomial that has a degree of 5 and we're given 3 of the zeros. So we need to find the remaining zeros. So we know this is a degree of 5, and knowing that there's a degree of 5, we know that there's going to be 5 zeros. So right now they gave us 1, 2, 3. Now we know with the I, if we have a complex zero with an I, we're going to have the conjugate pair. So with 1, that's just a 0. The 5i. Now the conjugate is we add that negative, so negative 5i. Now looking at 1 plus I, again, just add that negative to the I. So here's our first one that they gave us, and then our conjugate of minus I. All right, so that is our 5 zeros, 1, 2, 3, 4, 5. Next, we are trying to find a polynomial with the degree of 4. So that means we're going to have 4 zeros. They gave us 3. 1, 2, 3. So we're missing 1. We can write down already what that fourth zero is, or we can just start going into trying to find that polynomial. So we know if we have a 0 of 1, we have x minus 1. We have another one, so x minus 1. We have the one they were given, so x minus that 0 plus I. And then the conjugate pair of negative 4 plus I, just again change that I to negative, so 4 minus I. So then we have x minus negative 4 minus I. So let's start simplifying this. I'm going to start with the x minus 1 times x minus 1. I'm going to go ahead and FOIL. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is 1, so plus 1. Combine like terms here, and we get x squared minus 2x plus 1. There we go. Now let's look at the next two and start simplifying within those parentheses first. We want to distribute that negative to both terms in each one. So for this first one, we're going to have x. Negative times the negative is a positive, so plus 4, and then minus I. And then x plus 4 plus I. Now let's FOIL with these. When I have more than 2 terms, I like to use the box, but you can use whichever way you like, a FOIL or the box. So I'm going to go ahead and use the box here. So 4 minus I, x, 4, and then I. I just think this way I'm able to look at my terms more easily and not get anything lost and really just keep it organized. So I do, for like this box, I do x times x. So that would be x squared. For this second box, it would be 4 times x. So I'm hoping you're seeing the pattern here. So 4x. Negative x I. 4 times x is 4x. 4 times 4 is 16. 4 times negative I is negative 4i. X times I is xi. 4 times I is 4i. Then negative I times positive I is negative I squared. Okay, so now I can start looking at this and combine my like terms. So right here I have just 1x squared, and then I have 2 4x's. So 4x plus 4x is 8x. Then I have a 16 all by its lonesome, so plus 16. If I look at this negative xi and positive xi, they cancel each other out, so we don't have to worry about it. Then also this negative 4i and positive 4i. Now we have just that negative I squared. And if we remember, negative I squared equals 1. So we could replace that negative I squared with 1, so plus 1. And then 16 plus 1 is 17. So now I'm going to replace that 16 plus 1 with a 17. All right, so now I'm going to go back, and I have my two polynomials again that I'm going to multiply with each other. So here's my x squared plus 8x plus 17. Again, I'm going to use the box to figure this one out. So I have x squared, negative 2x, 1, x squared, 8x, and then 17. X to the fourth, negative 2x cubed, x squared, 8x cubed, negative 16x squared, 8x, 17x squared, that is negative 34x, and then 17. So now I'm just going to go ahead and combine those like terms. I'm going to move these things up a little bit so I can get some more space. So I only have one x to the fourth, and then I have these two x cubes. So 8x cubed minus 2x cubed is 6x cubed, so plus 6x cubed. I'm going to go in with the x squareds. I got a 17 minus a 16, so that's x squared, and then x squared plus x squared is 2x squared. Next, I'm going to look at those x's, and we have a negative 34 and an 8, so that equals negative 26. Whoops. And then plus 17. So that is our polynomial with a degree of 4. I'm going to go ahead and shrink this just so we can see the next problem. Okay, for our last one, we are given a polynomial, and we need to find the complex zeros. So the first thing we know is that this has a degree of 4. So that means we're going to have 4 zeros. So degree of 4, which equals 4 zeros. So we need to look for 4 zeros. The second thing, I'm looking at this and I'm thinking this is a lot of values, a lot of variables. I can't factor this. So what I'm going to do is I'm going to go look at the graph. So look at the graph. Step 2. Step 1, determine the degree and the number of zeros. So I'm going to go to my calculator here. I already entered in the function for us, so I'm going to go ahead and hit plot. All I need to find is one of those x-intercepts. So this one on the right side does not look like it will be an even number. So let's go check the 0 of this function on the left side. And it looks like the 0 is x equals negative 2. So 3. We know, or we're going to check, that one of them is x equals negative 2. And we're going to check this using synthetic division. So negative 2 we're going to put in the box, and then we're going to put the coefficients of each piece of the polynomial. So 3, 5, 25, 45, negative 18. Okay, we start by dropping a 3. 3 times negative 2 is negative 6. 5 plus negative 6 is negative 1. Negative 2 times negative 1 is 2. 25 plus 2 is 27. 27 times negative 2 is negative 54. 45 plus negative 54 is negative 9. And then negative 2 times negative 9 is 18. So we have a remainder of 0, which means that x equals 2 was a 0 of this function. So when we have x equals 2, we know to put it in the form of x plus 2. And then we did synthetic division, so we're going to rewrite that as another, and this will be another polynomial of 3x cubed. We do the highest degree minus 1. So our highest degree was 4, so now we're at 3. That's why it's 3x cubed. And then minus x squared plus 27x, and then minus 9. I want to continue factoring the 3x cubed piece. And so what I'm noticing is I can do factor by grouping. So I'm going to keep the x plus 2 and then do 3x cubed minus x squared, and then 27x minus 9. And I'm going to group those and see what they have in common. So 3x cubed and x squared both have an x squared in common. So if I take an x squared out, if I do 3x cubed divided by x squared, I just have a 3x. And then x squared divided by x squared is 1. In my 27x minus 9, they both have in common 9. So 27x divided by 9 is 3x. And then 9 divided by 9 is 1. And then don't forget our x plus 2. So we notice that when we just factored by grouping, our parentheses are the same. So that means we did this right. So we can just combine what we factored out. So the x squared plus 9, and then the 3x minus 1. So now here's where we can find the other zeros. So we know we're going to set each one equal to 0. So we have the x plus 2 equals 0, the x squared plus 9 equals 0, and the 3x minus 1 equals 0. So let's start with the first one. We're going to subtract 2 and end up with x equals negative 2. Let's go to the last one. So we're going to add 1 to both sides. 3x equals 1. Divide by 3. We get x equals 1/3. All right, now let's look at this middle one. Let's start by subtracting that 9. So we get x squared equals negative 9. To get x squared alone, to just solve for x, we're going to square root both sides. And then what's the square root of negative 9? If we have that negative, that's where that complex 0 comes in, of having 3i, but also having that negative 3i. Because remember, negative 3 times negative 3 would also equal 9. And also 3 times 3 equals 9. So you have to have that positive and negative. So those conjugates again. That's why we have those conjugates. And then those are our zeros. So the zeros, so therefore the zeros are x equals negative 2, 3i, negative 3i, and 1/3. All right. Please ask me questions if you need help.